Welcome to this unit on image analysis. In this lesson, we will learn how to export a matrix to an image file. You will see how a numerical matrix, which stores pixel values, can be converted into an actual image format such as TIFF, JPEG, or BMP. Understanding this process is important because it bridges the gap between numerical data in MATLAB and standard image files that can be viewed and shared outside the programming environment. In this homework, you will use Microsoft Excel to simulate how digital images can be represented as numerical matrices. Each entry in the spreadsheet corresponds to a pixel in an image. In Module 3, Homework Part A, you will create a matrix of zeros and ones. Each value represents the state of a pixel, like a light bulb that can only be turned on or off with a toggle switch. When arranged in rows and columns, these binary values come together to form a simple black and white image. In Module 3, Homework Part B, you will extend this idea by creating a matrix of 8-bit integers where each pixel can take a value between 0 and 255. This is like a panel of bulbs controlled by dimmer switches, where different brightness levels produce different shades of gray. Together, the pixels in the matrix form a grayscale image. When you open the Excel file, you must enable the macro. The macro allows the numerical values you type into the spreadsheet to be visualized as an image on the panel display to the right. Because this feature depends on macros, you must use the desktop version of Microsoft Excel. Cloud-based versions of Excel do not support macros, so please do not use them for this assignment. Completing this homework is very important because it builds the foundation for the rest of the unit. By practicing with Excel, you will clearly see the connection between raw numbers in a matrix and the images they represent. This exercise will help prepare you to export image data into standard formats using MATLAB. When exporting a matrix to an image file, the first step is to determine the correct data type for the output image. For a binary image, each pixel has only two states: on or off. In MATLAB, this is represented by the Boolean data type called logical. For a gray-level image, each pixel can have 256 possible values, ranging from 0 to 255, to represent different brightness levels. In MATLAB, this is represented by the unsigned 8-bit integer data type, written as UINT8. On this slide, the name is color-coded to help you remember: U for unsigned, int for integer, and 8 for 8-bit. Please be careful with the spelling. It must be typed exactly as UINT8, not Unit 8. A single misplaced letter will cause MATLAB to reject the command. Once you have chosen the correct data type, you can convert your matrix by calling the appropriate MATLAB function. Use the logical function to convert a matrix into a logical array, and the UINT8 function to convert a matrix into an unsigned 8-bit integer array. Once you have converted a numerical matrix into the correct image data type, the next step is to save it as an actual image file. In MATLAB, this is done using the imWrite function. The prefix im stands for image, so you can think of it as imagewrite. The function takes two inputs. The first is a variable that holds your image matrix, and the second is a file name written as a string in single quotes. In our example, the first line creates a variable called filename and stores the text myfirstimage.tif. That text is simply the desired file name. The next line calls imWrite. The first argument, imb, tells MATLAB which matrix contains the image data. The B here is capitalized, following the instructor's naming convention. IMB means image binary. We will use this convention consistently throughout the course to clearly indicate the type of image represented by each variable. The second argument, fill a name, provides the name to use when saving. Together, these two inputs export the matrix in IMB as an image file called myfirstimage.TIFF. Remember, the file is saved to the current working directory unless you provide a full path, and the file extension such as .tif, .jpg, or .bmp must be included inside the quotes. Forgetting the quotes or misspelling the extension is a common error. That concludes our lesson on exporting a matrix to an image file. In this unit, we learned how to choose the correct data type, logical for binary images, and UINT8 for gray-level images, and how to save a matrix as an image file using the imWrite function. If you have any questions, now is a great time to ask. After that, please remember to complete the hands-on practice activity for this unit. Following the step-by-step exercise will help reinforce today's concepts and make sure you can apply them confidently in MATLAB.